Alright, how's it going? In this video, we're going to look at logarithmic functions and their applications. This is the first lesson on logarithmic functions. I'll have this video and two more, I think. So there'll be about three altogether. So the thing about logarithms is you've got to understand the properties. Okay, you've got to know what the properties mean. If you don't know the properties, you're not going to be able to work the problems. Okay, that's where most students miss the problems. So let's go ahead and look at this. So this is just kind of introducing you to logarithmic functions, some basic things that you need to know, and then the next video or the next section in a college algebra book deals with the logarithmic properties. All right, so here we have definition logarithmic function. So it says for a positive constant a with a not equal to 1, the logarithmic function with base a is denoted by f of x equals the log of x with base a. Now this right here, this log of x base a, that's log x with base a. I know I write it kind of messy, but that's what it is. Okay, so we have y equals the log of x with base a if and only if a to the y equals x. So what this is this is telling us how to convert from logarithmic form to exponential form, and from exponential form back to logarithmic form. That's what this is. You've just got to know this. Okay, you've got to remember that. And really, it's not that hard to remember. If you have it written like this, just remember, see, the base of the log is the base of your exponent. So it's just this raised to this equals this. You go over and back across. So this raised to this equals this. And that's all it is, really. Okay, converting from log to exponential form. And then we have common and natural logarithms. So the common logarithmic function is denoted as f of x equals the log of x. Okay, where y equals the log of x if and only if 10 to the y equals x. And the natural log function is denoted by f of x equals, and this is ln, that it would look like this. Let me write it in a different color. ln x, I just write it like that. Natural log x, where y equals the natural log of x if and only if e to the y equals x. So, you know, you don't really need to remember these as long as you know this one, okay? So what you have to get out of this is you've got to understand that the log of x is the same thing as the log of x with base 10. Okay, so if there's not a number here on the base, it's understood to be a 10. All right, so you can see if that's a 10 right here, this base, that would be 10 to the y equals x, and that's where this comes from. All right, and then the other thing is this right here, this natural log. So you've got to remember natural log x is equal to the log of x with base e. Okay, so whenever you see ln, just picture an e right there on the base. Okay, picture this to be log base e. All right, and see, so if you have natural log x, then that's log x base e. So this right here is considered to be, this is an e if you see ln. So that's an e. So you can see e to the y equals x. And there's this e to the y equals x. All right. That's very important. So students miss this all the time because for some reason they don't grasp the concept that log no number is base 10 and ln is base e. Okay, it's used so often in math. Is log with no number, it's an abbreviation for log base 10. Same thing here, log base e, instead of writing log with the base e, we write ln to abbreviate it. All right. So here we've got some examples. So it says write each equation involving logarithms as an equivalent exponential equation, and write each equation involving exponents as an equivalent logarithmic equation. So we're going to convert from, if it's in logarithmic form, we're going to convert it to exponential form. If it's in exponential form, we're going to convert it to logarithmic form. All right. So remember, to convert, we've got logarithmic form. So remember, the base of the log is the base of the exponent. So it's this raised to this equals this. Remember, you go over and back across. Okay, so that's going to be 5 to the 4th equals 625. And then same thing here. We're going to go over and back across. So that's 3 to the 5th equals n. All right, so what about this? Now we're going from exponential form to logarithmic form. Now, the way that I like to do this is, I think this is the easiest way to do it. Now, also, what I want to say before I do that is what I would do if I were you on a test. I would just write this down. Just write down y equals log x base a, convert it, and then you've got this property here. All right, so to convert this, I've got log. All right, now what do we know? We know the base of the exponent is the base of the log, right? We know that. And then let's leave a little space and put an equal sign. So what is that? That's 3 raised to this power over here, right? Well, what goes here? The exponent, x. And then the 50 goes here. And there's your answer. Okay. Same thing here. This is what? Log base e, right? Log base e, but I'm not going to write log base e, am I? I'm going to write what? Natural log. Remember, that's the same thing as log. I tell you what, let's do this. Let's just leave it, log base e equals, and then it's e raised to this power. Well, what's our exponent? X minus 1. And then the 9 goes here. And so remember, we're not gonna write log base e. That's what? Natural log of 9 equals x minus 1. All right. And so this is your answer. Now this step right here, you don't have to show that step. I just did it so you can see it. Okay. All right. Now what about this? Well, there's no base, is it? So what is this understood to be? That's understood to be a 10. Now you don't have to write the 10. I just put it in there so you could see it. All right. So that's what? 10 squared equals 100. And there's your answer. Now what about this one? Natural log x equal 2. Well, natural log, that's understood to be what? Base e, right? So it's e raised to the 2nd equals x. And there's your answer. All right. All right, so these problems. Find the indicated values of the logarithmic functions. All right, so we want to evaluate these, okay? And we're not using a calculator. Now, there's a property that in a lot of college, I think probably all the college algebra books I've seen, this property that I'm fixing to show you is in the next section. But I go ahead and I bring it into this section because that's how you're going to evaluate these things anyway. You're going to use that property in the next section. So I just show it to you in this section, and that's how That's how you're going to always do it. So there's a property that says the log of a to the x with base a is equal to x. Okay. Now, if you watch the next video, you're going to see this property again. Okay, you'll see it again. All right, so what this is saying is if you're taking the log and the base of the log and the base of the exponent are the same, then your answer is your exponent. Okay, so if these two are the same, then your answer is your exponent. So let's use that to evaluate these. So I've got the log of 9 with base 3. Now, if you've watched my other videos, or if you're in my class, then you watched this previous video on exponential equations, when we solved the exponential equations. And when you solve an exponential equation, you get the bases the same, and then you set the exponents equal to each other. That's kind of what we're doing here. But you see how we've got log base 3? Well, look at this. I can take 9. Can I rewrite 9 as 3 raised to a power? Yeah. That's 3 squared, right? 9 is the same thing as 3 squared. All I did is I rewrote 9 as 3 squared. Now, you can see here the base of the log, the base of the exponent are the same, so my answer is my exponent 2. Okay. Now it's important that you get this, what we're doing right now, because we're going to do this. We're going to use this in a minute when we start graphing these things. All right, so let's look at this one. So the base of my log is 2. Well, can I rewrite 1/4 as 2 raised to a power? Well, let's look at that. So that's log base 2, and 1/4 I can write as 2 squared. Okay, so I'm getting there. Okay, I don't have 1/4 written as 2 raised to a power. I have it written as 1/2 to a power. Well, I know that this is log base 2. Now, remember, if you move this across the fraction bar, it changes the sign of the exponent. So that's 2 to the negative 2. So all I did is this 2 squared, I moved to the numerator, and that changes the sign of the exponent. Now the base of the log, the base of the exponent are the same. So my answer is my exponent, and I get negative 2. Okay. See, this stuff isn't that bad. It's not bad at all. All right, let's look at this one. So this is log, base is 1/2. Now, I've got to see if I can rewrite 8 as 1/2 raised to a power. Well, I know 8 is 2 cubed. Okay? Now, I need 1/2 to a power. Well, look at this. I've got what? I've got 2 cubed. Isn't that just like this? That's the same thing, right? 2 to the 3rd. I can put that 2 in parentheses. Now, the other thing I want you to see is that 2, isn't 2 the same thing as 2 over 1? And I can take the reciprocal. All right. So what happens if I take the reciprocal of the fraction? That's right. It changes the sign of the exponent. So 2 cubed I can write as log base 1/2 of 1/2 to the negative 3. All right. And so the 1/2, those are the same. So my answer is my exponent. And there's your answer. All right. So how about this one? Log of 1,000. So this is going to be what? Log of, now the 1,000, what do I have to write that as? What does the base, what's the base? Well, remember, the base is understood to be 10. Well, 1,000 is what? 10 cubed. So you can see the base of the log, which is 10, is the same as the base of the exponent. So since those are the same, my answer is my exponent, which is 3. Now what about this one, log of 1? Okay. Well, there's a property for that. It's not in this section, it's in the next section. But remember this, anytime you take the log of 1, no matter what the base is, you get 0. Okay? The log of 1, no matter what the base is, in this case, what's the base? That's right, it's base E. All right? But no matter if the base is 2, 3, 4, 5, 1/2, 2/3, square root of 2, whatever it is, whatever that base is, if you're taking the log of 1, it's 0. Now, what about this one? The natural log of -6. What would that be? Well, this is undefined. Okay? Undefined. Remember, you can't take the log of 0 or a negative number. Okay? You can only take the log of a positive number. All right? All right, so what about this one? Well, this is easy, isn't it? That's what? 5. See, the base of the exponent is what? E. What's the base of the log? Well, it's natural log, so the base is understood to be an E. So since those E's are the same, your answer is your exponent. All right? All right, so that's evaluating the logarithms. All right, now let's look at graphing these things. All right, so graphing these, it's going to be similar to the way you graph the exponential functions, okay? Remember you graphed y equals 2 to the x, those kind of problems? Well, it's going to be the same process. We're going to pick points. We're going to pick values for x, plug it in, get the y value, plot the points, and draw the graph. All right. And this should be y equals or f of x equals whatever you want to put. All right. So we're going to make a table. I've got x, y. And I'm going to choose values for x. All right. So if you watch my video on graphing on the exponential functions, we graphed exponential functions there. And you could pick any value you wanted for x. Okay. But if you remember, I said if you pick your x values a certain way, it makes it easier to graph. And that's the same thing here. For logarithms, you can pick any x value you want as long as it's in the domain of the function. Okay? You can pick whatever you want. And we'll talk about this later, but the domain of the logarithmic functions that's in this form here is 0 to infinity. Okay? You can pick any number from 0 to infinity. Remember, we just talked about that right here. You can only take the log of a positive number. All right. So here, you can pick any x value that's in this domain. But if you pick your x values a certain way, it makes it so much easier to graph. The first thing I want to do, take the log of 1, because I know if I plug the 1 in, that's going to give me 0 as an answer. Okay, and then I want to choose 2, 4. Okay, now why am I choosing 2 and 4? Well, that's because my base is 2. So if I plug the 2 in, these 2's are the same, so my answer would be my exponent. 4, I can rewrite that as what? 2 squared. You see that? Pick your x values so you can evaluate this thing like we did up here, right? You want to pick something where you can rewrite this as an exponent that has the same base as the base of your log. Okay. Now the other thing we want to do, so I picked these values. Now I want to pick some values that will give me negative answers. I want to get negative answers. So if you notice here, do you see how I took the log of this fraction and that gave me a negative answer? Okay, so I want to pick some fractions. So let's see, what do you think we're going to pick? Well, that's right, we're going to pick 1/2 and 1/4. Okay, now this is how you want to choose your x values. It's the easiest thing to do. Okay, it's the easiest thing to do. So let's just look at this. If I had log x base 5, let's say I had that. How would I want to choose my x values? What would I choose? I would choose 1, right? And then I would choose what? 5, 25, 1/5, 1/25. Because see, all of these can be written as 5 raised to a power. All right? Or if I had log, I don't know, if I had log log of x with base 7, that's an x. I would choose what? 1, 7, 49, 1/7, 1/49. You see that? That's how you want to choose your values. Do you have to do it like that? No. But if you want to make it hard on yourself, then just pick anything, okay? But the whole point of this is to make it easy, right? All right, so let's evaluate these. So I've got y equals log of 1 with base 2. Well, we know that's 0. Y equals the log of 2 with base 2. Those are the same, so that's 1. Y equals the log of 4 with base 2. So that's the log of 2 squared with base 2, which equals 2. Y equals the log of 1/2 with base 2, which that's the log of, now the 2 I can move up. So that's 2, and then that changes the sign of the exponent. See, that's 2 to the first, and when I move it up, it changes the sign of the exponent, so that's -1. And then y equals the log of 1/4 with base 2. So that's the log of 1/2 squared with base 2, which is the log of 2 to the -2 with base 2, which equals -2. And so I've got 0, 1, 2, -1, -2. All right. And you remember how we did log base 5 and log base 7 over here, and I chose my x values. If you choose your x values, your y values are going to be 0, 1, 2, -1, -2 every time. Okay. All right, so now let's graph this thing. All right, so if we graph this, all right, so there's 1, 2, 3, 4, 1, 2, 1, 2. So let's plot our points: 1, 0, 2, 1, and 4, 2. And then I've got 1/2, -1, 1/4, -2. And our graph is going to look like this. Okay, and that's your graph right there. Okay, now the one thing that you've got to make sure of, you cannot draw it like that. Okay, if you draw the graph crossing the y-axis, that's wrong. It's never going to touch it. It's never going to cross it. Okay, because look, if you draw your graph over here, then what you're telling me is you put in some x values that were negative. And remember, we just said you can't take the log of a negative number or 0. So don't cross that. Now, let's look real quick. If you remember y equals 2 to the x, when that was graphed. So we had an xy table. So that was what? 0, 1, 0, 1, 2, -1, -2. And when you plug the 0 in, you get 1. Plug 1 in, you get 2. 2 squared is 4. 2 to the -1 is 1/2, and this would be 1/4. Okay, so let's just plot that on the same axis. We'll do it in a little bit different color. So I've got 0, 1, 1, 2, 2, 4, and then I've got -1, 1/2, -2, 1/4. And when we draw this graph, it looks like this. So do you notice anything? If we draw this line here, y equals x, these are inverses of each other. Isn't that neat? And also, if you look, you remember when you covered inverse functions, if you had a set of points and you had a relation, you had a set of points, what was the inverse? You just swapped the x and y values, right? Well, look at this. See this? It's just that the x and y values are swapped. Look at that. See that? Isn't that the best thing you've learned all day today? Okay. So they're inverses. All right, so let's look at another one. All right, so let's make a table. So I got x, f of x. And so I'm going to choose 1 first. And then my base is 1/3, so I'm going to choose 1/3, 1/9, 3, and 9. Okay, because I got to rewrite everything as 1/3 to a power. And look, we did that up here, didn't we? Look at this. See this? How we wrote 8 as 1/2 raised to a power. Okay. All right. So let's evaluate this. So I get y equals log 1/3 of 1 equals 0. Y equals log 1/3 base. That's 1. See, the bases are the same. The exponent's a 1. Y equals log 1/9 base 1/3. So that's log base 1/3. 1/9 is what? 1/3 squared. The bases are the same, so my answer is my exponent, 2. All right, so now we've got y equals the log of 3 with base 1/3. All right, so this goes back to that one we did a while ago. So that's what? Log, the reciprocal of 3 is what? 1/3. Because see, that's 3 to the first power. So if I take the reciprocal of 3, which is 1/3, it's going to change that first power to a -1. And so that's 1/3, so that's -1. And then I've got y equals the log of 9 with base 1/3, which is the log of base 1/3 of 3 squared, which is the log base 1/3. And then the reciprocal of 3 is 1/3, so that's going to change that from a +2 to a -2. And so that's 0, 1, 2, -1, -2. All right. So now all we do is we plot our points. And so let's see what that gives us. All right, so we got to go all the way out to 9. So let's see. Let's do 1, 2, 3, 4, 5, 6, 7, 8. 9. Then we got 1, 2, 3, 1, 2, 3. All right, so let's plot 1, 0, and then 1/3, 1, which that's going to be about right there. 1/9, 2, it's going to be about right there. 3, -1, and then 9, -2. And so our graph will look like that. And once again, this thing will never cross the y-axis. Okay, if you draw it touching or crossing the y-axis, that's wrong. Okay. All right, so now let's look at some properties of logarithms. I did this in the video that I did on exponential functions, that lecture, did properties of that. So kind of the same thing here. So the logarithmic function f of x equals log x base a has the following properties. The function f is increasing for a greater than 1 and decreasing for a between 0 and 1. So they're looking at the base there. So that's exactly what it says. If the base is larger than 1, which it is here, you see how the graph is increasing, okay? And then it says if the base is between 0 and 1, like this one, see how it's decreasing? That's what they're talking about there. The x-intercept of the graph is 1, 0, and if you notice, that was where it crossed the x-axis every time in both of them. 1, 0. See that? The graph has the y-axis as a vertical asymptote. We talked about that a little bit in the exponential video. The asymptote, that's the line that the graph is not going to touch or cross. It's just going to get real close to it. And it says the y-axis is a vertical asymptote. And that's what they're talking about here, this y-axis. What I mentioned is it gets close to it, but it's never going to touch it or cross it. Let's see. The domain is 0 to infinity. Okay, so I talked about that. The domain, the numbers you can take the log of, has to be positive. You can't take the log of 0 or a negative number. And so there your domain is 0 to infinity. And then the range is negative infinity to positive infinity. You can see this thing's going up forever. It's going down forever. Yes, it's going right, but it's also going down. And same thing here. It's going down forever, and it's also going up forever. So the range, the y values that it's going to hit is negative infinity to positive infinity. The function of f is 1 to 1. Well, of course it is, because earlier I just said what? That this right here, y equals 2 to the x, is inverse of y equals log x base 2. Okay, so it's 1 to 1, and we can even see that from the graph. It passes the horizontal line test. Okay, remember that? If you draw a horizontal line through a graph and it only intersects the graph at one point, that means it's 1 to 1, and it has an inverse also. And the functions f of x equals log of x with base a, and f of x equals a to the x are inverse functions. Well, that's what we just talked about with log x base 2 and 2 to the x. All right, so now we've got some more that we're going to graph. And to graph these, you can take, like for this first one here, log of x minus 1 with base 2. Now to graph that, you could take this and it would just shift it 1 unit to the right. Okay, but in order to do that, you would first have to graph this function, log x base 2. You would have to graph that. Okay, so what we're going to do here is just know that you can shift them left, right, up, down. You can reflect them and all that stuff. But what I'm going to do, let's just look at it. Let's pick some x values, plot points, okay, and then graph it. Okay, so let's do that. Now, let's make an XY table. So I got X, Y. So I've got to choose my X values. So remember what I said, how to choose them, right? So I'm going to do what? 2, 3, 5. You see that? 2, 3, 5. And this right here is where it kind of gets, I don't know, I guess it kind of gets kind of tricky. I'm going to choose what? 3 halves, right? 3 halves. And then I want to choose what? Can you think of what we want to choose next? 5/4. Okay. Now, why did I choose those values? Well, let's see. And then I'll talk a little more about the fractions. All right, so if I do y equals what? Log 2 minus 1 base 2, which is log 1 base 2, which is 0. Y equals log 3 minus 1 base 2 equals log of 2 with base 2, that equals 1. Y equals log of 5 minus 1 with base 2 equals log of 4 base 2, which equals log of 2 squared base 2, which equals 2. All right. So that's not bad getting those. So we got 0, 1, 2. Now, hopefully you see why I chose those x values, okay? Because what happens is, see how when I chose the 2, the 3, the 5, I ended up getting the log of 1, log 2, log 4, just like in the earlier problems, okay? Now, as far as the fractions go, that's a little more involved. So the 3 halves, why did I choose that? Well, because I know 3 halves minus 1 is 1 half. And why did I choose the 5/4? Because I know 5/4 minus 1 is 1 half. I mean 1/4. Okay. So what you could do, you've got x minus 1. Okay, that's what you're taking the log of. Well, we know for when we take the log, this number here, after we plug the x value in, we want this number in this case to be a 1 half, and here we want it to be a 1/4. You see that? So you could just add 1 to both sides, and that gives you x equal 3 halves. Add 1 to both sides, that gives you x equals 5/4, and that's where your x values come from. So it's not as nice as the ones we did before. It's a little more involved, a little more complicated, but that's just how it is. Okay. The other option you have is to shift the graph, but if you think about it, you know, you're still going to have to shift it. So let me get up here. Okay, so like right here, see this right here is a value, x value of 1 half. Well, it was x minus 1, so that shifts to the right 1 unit, right? So you're still going to have to take this fraction and shift it to the right 1 unit and get that fraction of 3 halves. And same thing here, you'll have to get that fraction of 5/4. Okay. All right. So, you know, either way, you're going to have to add fractions and stuff like that. And so let's see here, I'm going to get y equals the log of base 2, and that's going to be 3 halves minus 1. Okay. And so that's the log of, that's 1 half base 2. which is going to be the log of 2 to the negative 1 base 2, which is negative 1, and y equals the log of base 2, 5/4 minus 1, which equals the log of 1/4 base 2. And we've done this before. We know that this is going to be negative 2. We'll go ahead and write it to save time. I mean, we solved that one a bunch while ago. All right, and so there's your points. So now let me erase some of this so we'll have room to draw the graph. And so here, so I've got 1, 2, 3, 4, 5. 1, 2, 3, 1, 2. All right, so I've got the point 2, 0. I've got 3, 1, and 5, 2. And then I've got 3 halves, negative 1, which is there, and 5/4, negative 2. And so your graph is like this. All right, now remember, y equals log of x with base 2. Remember, that graph would never cross the y-axis, okay? And the y-axis is where x is 0. But remember, this x minus 1 here, that's going to shift to the right 1 unit. So that means it's going to shift this right here 1 unit as the line that it's never going to cross. And so you're going to have to draw in that vertical asymptote there. Okay. Now, if this was minus 2, then it would shift 2 units. We would draw the vertical line at 2. If this was plus 1, we would draw the vertical line over here at negative 1. Okay. All right, so how about this one? Well, let's look. So I've got x, f of x. So let's choose our values. So I'm going to choose what? Negative 2, all right? Negative 2, negative 1, 1, okay? And then I've got to pick a number that's going to give me 1/2 as an answer. So I need x plus 3 to equal 1/2. Well, if I subtract 3 to both sides, okay, so that's going to be what? What is that? Negative 5/2, I believe. That's negative 6/2. Yeah. So I'm going to pick negative 5/2. And then I need x plus 3 to equal 1/4. So if I subtract 3 to both sides, that's going to be what? Negative, is that negative 11/4? I'm going to check it and make sure. Yep. So there's our x value. So you see how to do this. All right. So now we got to plug them in, and I'm gonna plug a couple of them in, and then I'll write the answer down. So here I get y. Let me do it in a different color. So y equals negative 1/2 times log of base 2. Now look, let's just go ahead and plug the negative 2 in. Negative 2 plus 3 is 1, and so that whole thing, that's just 0. Okay, y equals negative 1/2 log of negative 1 plus 3 is 2. All right. Okay, so this is what? 1. All right. So this is negative 1/2 times 1, which is negative 1/2. And then y equals negative 1/2 log of, well, look, if I plug the 1 in, 1 plus 3 is 4. So this is what? 2 squared. So this would be what? 2. 2 times negative 1/2 is negative 1. And then y is negative 1/2 log of, now remember, we plugged the negative 5/2 in. That gave us what? 1/2. And so I know this is what? This is negative 1, right? So negative 1 times negative 1/2 is positive 1/2. And then y is negative 1/2 times log base 2. Plug the negative 11/2 in. That's going to give me 1/4. And so this is what? That's negative 2. So this is going to be positive 1. Okay. So for our answer, we get 0, negative 1/2, negative 1, 1/2, and 1. And, you know, this right here would be good practice. If you want to, pause the video and go plug this in and show all the details. You know, so you should fill in all the steps that I didn't, but, you know, I think you can do that. All right, so let's see what we've got here. All right, so I've got 1, 2, 3, 4, 5. 1, 2, 3, 4. So I've got negative 2, 0, right? Negative 2, 0. Then I have negative 1, negative 1/2. Let's see, 1, 2. That would be about right there. Let me do this. Let me space that out a little more. The 1 there. So negative 1, negative 1/2. 1, negative 1. Okay. Then we have negative 5/2. Well, 5 over 2 is 2.5, so negative 2.5, which is about right here, and 1/2. And then negative 11/4, that's getting a little bit closer. That's going to be, let's see, 11 divided by 4 is 2.75. Now, let's think about this for a second. Remember, a normal log function, log x base a, vertical asymptote is here, right? At x equals 0. This plus 3, that's shifting it over, what, 1, 2, 3 units. So this is going to be your vertical asymptote here. And if we plot this point, negative 11/4, 1, that's going to be about right in here. Something like that. And so our graph is going to look like this. Okay, doesn't look very pretty, but it's good enough. All right. All right, so that was graphing these things. Now, remember we've talked about these things being inverses of each other also. Okay, so let's find the inverse of a log function. So remember, to find the inverse, you change f of x to y. Okay. We're just using that switch and solve method, how you learned how to find inverses earlier in your college algebra course. Okay, so we change the f of x to y. We swap the x and y, so we get x equals log y base 3. And then what do you think you do after that? Change it to exponential form. 3 to the x equals y, and then we change the y to the f inverse symbol. And there's your answer. Okay. Let's look at this one. All right, so y equals 1/6. I'm sorry. Equals 1/2 times 6x to the 3rd. Okay. Now let's go ahead and multiply by 2. So that's going to be 2y equals 6x to the minus 3. Okay. We don't want anything over there with that exponential function. Then we swap the x's and y's, so 2x equals 6 to the y minus 3. And then what do we do? Change it to logarithmic form. Okay, see, it's just backwards from this one. See that? See, this was a logarithm going to exponential. Find the inverse of a logarithmic function. Here we're finding the inverse of an exponential function. See the difference? So now just change it to logarithmic form. So remember, that's log base 6, right? See, log base 6. Let's leave a little space here. Now remember, it's 6 raised to this power. Well, what's the exponent? Y minus 3. And then the 2x goes here. And then I'll need to add 3 to both sides. So this is going to be y equals, all right, so that's going to be the log of 2x base 6 plus 3. And then we change the y to that f inverse symbol, log 2x base 6 plus 3. There's your inverse. Well, see, it's not bad. It's doing the switch and solve method. The only thing is you just got to convert it from log to exponential or exponential to log. All right, so what about this one? Here's another logarithmic one. And this right here, that is a 1. Kind of looks like a parenthesis. So y is, that's going to be log x minus 1 base 2 plus 4. Now, so I just changed the f of x to y. Now I want to get the logarithm because I'm going to convert to exponential form. So I want to get the logarithm by itself. So I'm going to have to subtract 4 to both sides. So that's y minus 4 equals the log of x minus 1 with base 2. And now we convert it to no, we don't convert it to exponential form. Being stupid there, aren't I? Okay, I guess what we should have done before we subtracted 4 to both sides is we should have swapped the x's and y's. Yeah, but I mean, it doesn't really matter. Let's just go ahead and swap them now. So I got x minus 4 equals the log of y minus 1 with base 2. Okay, now let's convert it to exponential form. So that's 2 raised to this. So 2 to the x minus 4 equals y minus 1. And then I'm going to add 1 to both sides. So I will get y is equal to 2 to the x minus 4 plus 1. And so change that to the f inverse symbol. That is 2 to the x minus 4 plus 1. And there is your answer. Okay. All right. One-to-one property of logarithms. We don't have many more. Just stick around. If you've hung in it this long, just keep watching. You got too much invested now. All right, so one-to-one property of logarithms. For a greater than 0 and not equal to 1, so the base is positive, not equal to 1. So if the log of x of 1 with base a equals the log of x of 2 with base a, then x of 1 equals x of 2. So what this is saying is if you've got the log, base a, those are the same, then to solve this, whatever you're taking the log of, just set them equal to each other. Kind of reminds you of that property solving exponential equations, right? If the bases are the same, just set the exponents equal to each other. All right, so let's go ahead and solve this. So there's a couple of scenarios you'll have. You will have a single log equals a number, or you'll have a single log equals a single log. Now, I'll get more into detail in this one in another video, not the video after this one, but the one after that, the one on logarithmic equations. Okay, these are just real basic ones. So you'll come up with these two scenarios. You'll have a logarithm by itself on one side of the equal sign and a number on the other side, or you'll have single logarithms on both sides, like this one, like a single logarithm equals a single logarithm. That's what that means. All right, so if you have this one, then convert or rewrite it in exponential form. Okay, if you're taking notes, write that down. Single log equals a number, rewrite it in exponential form. If you got a single log equals a single log, use the one-to-one property. Okay, like I said, if you're taking notes, write that down what I just said. All right, so you can see here we've got this, don't we? So we're going to convert it to exponential form. So this is 3 to the negative 2 equals x. And so I get x is equal to 1 over 3 squared. X equals 1/9. And there you go. All right, so what about this one? Well, I've got single log and a number, don't I? So let's rewrite it in exponential form. So that's x squared equals 5. Okay. Well, we've seen this before, haven't we? This is square root property. So x equals what? Plus or minus the square root of 5, negative square root of 5, or x equals square root of 5. But what do we know? We know the base cannot be negative. That's not one of your answers. It's just this one. The base has to be positive. All right, so what about this one? Oh, this is an exponential. Oh, and look at this. Remember what happened earlier? When we solved exponential equations, we had to get the bases the same, didn't we? And then after we got the bases the same, we would set them equal to each other. Try getting those bases the same. Can you do it? You can do it, but it'll take you forever to figure out what the exponent has to be. 5 raised to what equals 9? Well, actually, that's what we're trying to find, aren't we? So you can't get the bases the same. This is something kind of quick that I'm going to show you how to solve this, but in that section on logarithmic equations and exponential equations, we're going to come back to all this, where the exponents are going to be more complicated than this, and I'll show you another way to solve it. But look, if you take this and just convert it to logarithmic form, so that's the log of what? The base of the exponent is the base of the log. Let's leave our space there. 5 raised to the x is our exponent, and 9, and there's your answer. X equals log of 9 with base 5. Okay, I promise we're almost finished. We've got a few more of these, which don't take long, and then we've got your favorite one-word problem to do. All right, so let's look at this one. Well, what is this? This is the one-to-one property, right? I finally got my single log equals a single log. So remember what this is. Whatever we're taking the log of, we just set equal to each other. X squared equals 3x. So now let's solve this. So I'm going to subtract 3x to both sides. So that's going to give me x squared minus 3x equals 0. I'll factor out of x. And so I get x equals 0 or x minus 3 equals 0. So I get x equals 3 or x equals 0. Now, I haven't mentioned this up to this point, but now I've got to mention it. So if you remember when you solve those miscellaneous equations, that's always the fun chapter, the fun section in college algebra, those miscellaneous equations. When you solve square root equations and you had to square both sides, and after you solved it, what did you have to do? You had to plug everything back in, make sure it worked, right? You had to check your solution. Well, we need to do that here. But you don't have to go to the point of what you did back then. You don't have to make sure you get the same thing on both sides. You can, but you don't have to. What we've got to do is we've got to take these values and plug them back in. So if we plug the 0 in, what is 0 squared? 0 squared is what? 0. Can we take the log of 0? No. So that's not a solution. So what you've got to do is you've got to plug these in, and you've just got to see if when you plug them in, do you get a negative number or 0 in here? If you get a 0 or a negative, then it's not a solution, because you can't take the log of 0 or a negative number. And see, if I plug the 3 in, well, 3 squared is positive. 3 times 3 is positive, so I'm good. And that's all you got to check. All right, so what about this one? Well, that's like the one we did up here, isn't it? That's like this one. We'll convert it to logarithmic form. So this is going to be what? Log, there's my base, right? So leave a space. So that's what? This raised to this, so that's x, and then the 50 goes there. Okay? Now, don't think too much into this. You might be wondering, well, why didn't you put the 10 down? Well, remember what we talked about at the first of the video, which was a long time ago? If there's not a number there, it's understood to be 10. And so there's your answer. All right, so what about this one? All right, so first thing, we've got an exponential, so I want to convert it to logarithmic form. So first thing I'm going to do is I'm going to divide everything by 2. So that's e to the 0.5x equals 3. Now let's convert it to logarithmic form. So this is log base e, but wait a minute, hold on a second. I don't write it like that, do I? Log base e is what? Natural log. Equals, so that's e raised to this power, which is what? 0.5x. You see that? And then the 3 goes here. Okay. Now I've got to do what? I've got to divide everything by 0.5. And when I do that, I get x equals the natural log of 3 over 0.5. And look, if you wanted to, you could write that as 2 natural log 3 equals x. That's acceptable too. Think about that one for a minute. See if you can't figure out how I got that. I'm not going to tell you in the video. Just, I'll give you a hint. Remember, 0.5, that's the same thing as 1/2. So the 2 flips up. I guess I did tell you, didn't I? All right. So let's look at this one, and guess what? This is the last problem. Okay. So it says, if $8,000 is invested at 9% compounded continuously, then how long will it take for the investment to grow to $20,000? So what's the formula? Do you remember that? Well, I think we did one of these we did in the exponential functions video. So the formula for continuous compounding is A equals P times e to the RT. Okay. Now, well, let's plug all the numbers in that we have, and they want to know how long will it take. So I'm guessing we're solving for t, because t represents time in years. So we've got, let's see, if 8,000 is invested, so P is 8,000 at 9%, so R is equal to 0.09 compounded continuously, then how long will it take for the investment to grow to 20,000? So basically, I'm putting all this in, and I want to know when will I get 20,000. So, so we've got A is 20,000. So let's plug everything in. So I got 20,000 equals 8 8,000 e to the 0.09 t. You see that? Well, look, that's kind of like what we did. Well, that's exactly what we did right here, right? Just the numbers are different. Isn't that what your teacher does a lot of times? They'll put the numbers just like the book, but they'll put the problems like the book, but change the numbers a little bit. So first, let's divide everything by 8,000. How about we do that? So that's going to give me 2.5, right? 2.5 equals e to the 0.09 t. And then what do? Convert it to what? To logarithmic form. So that's e, so that's what? Natural log, that's e, equals my exponent. Remember, it's e raised to this power. What's that power? 0.09 t. And that's natural log 2.5. And then I will divide both sides by 0.09. And so that's going to give me t is equal to natural log 2.5 over 0.09, which is equal to, and that's about 10.181, and that's, remember, t is in years. And there's your answer. So how fun was that stuff? All right. Now you feel smarter. You go tell all your friends what you learned. All right. So hopefully this helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.